it's very nice to see you once again, and I'm very glad that I have the great honor to announce our first keynote, who is coming from all the way from the Australia. We are going to listen to the first keynote from Oppermann, and his talk is Insight versus Privacy: How to Maintain Public Trust While Deriving Insight from Datasets. Basically, data sharing remains a challenge in many organizations. Very often, the concerns raised are around privacy, but in practice, the real concern relates to sensitivity of the data, data quality, and the impact of decisions made from insight generated from the data. This paper attempts to articulate those concerns and identify mitigation for them. The complexity of data lifecycles is also identified as a limiting factor for systematic data sharing. This paper attempts to identify conditions required to be in place before data is used and before data and data products are shared. This presentation identifies simplified frameworks of controls for data sharing along portions of the data lifecycles. This framework identifies points of control to address sensitivities and inherent risk of data sharing and use for different types of data. Without further ado, we are going to listen to pre-recorded keynote from our distinguished keynote speaker, Oppermann. Thank you.
Hello, my name is Dr. Oppermann. I'm the Chief Data Scientist for the New South Wales Government and also an Industry Professor at the University of Technology. And welcome to the presentation today, talking about insights versus privacy and how to maintain public trust while deriving insights from data sets. I want to take you through not only some of the work that's happening in New South Wales Government, but also try to bring to life an example of data sharing and use around COVID, something which unfortunately is still a very topical topic. On the screen at the right at the moment, you can see that bottom right-hand corner actually contains a COVID map that New South Wales releases every single day, which talks about confirmed cases, which talks about rates of testing, but is underpinned by raw data. So the example I'm going to leave you with today is how we actually use the frameworks we've been developing to not only release that map, which is insights, but also release raw data every single day, including today. Let's begin. Now, New South Wales has been on quite a data journey for quite some time. In 2015, New South Wales Government stood up the Data Analytics Centre, originally modelled off the Mayor's Office of Data Analytics in New York and some other places around the world. But over time, really has been driving forward the thinking about use of data, use of sophisticated algorithms, and increasingly trying to solve wicked policy challenges through the lens of data, deliberately in some cases recomplicating the problem through the lens of many, many different data sets in order to better understand that problem differently. Now, what we're currently doing is putting in place a series of strategies to represent or reflect the next stages of New South Wales' journey. And some of the framing, of course, we're thinking about are what do we need to build, what do we need to understand, what do we need to bring to life to be prepared for not today's problems, but for example, the problems of 2030. 2030 is a convenient time frame to think about because it's right at the edge of most people's strategic thinking about what the world might look like, what systems might look like. And of course, we know in Australia and many other parts of the world, we have an aging, urbanising population, also a growing population. We know that we're experiencing a changing climate, but we know we're also experiencing increased use of data and digital services, not only to service that aging, urbanising, growing population, but also to help drive forward the productivity that we need to have in order to not only maintain quality of life, but of course the expectation is that we'll increase that quality of life. So we can expect some technological trends beyond just use of data and digital, increased use of autonomous vehicles, increased telework, teleeducation, telehealth, increased use of smart grids, and whether they're energy grids or other sorts of grids, and certainly increased use of smart factories and smart systems. And that means increased use of AI, increased use of data to drive those smart networks or even generated from those smart networks, and increased use of digital services. Now, we also know, of course, that 2030 is the time frame that we're looking at for the UN Sustainable Development Goals. And in my day job, there are a couple of those goals that are really very, very important. Not only Goal 11, smart cities, but also a whole series of goals which relate to the built environment, the natural environment, and how we operate together as a society. So by framing this problem in terms of what we're thinking about from our strategy development, I'm now going to talk a little bit about some of the strategies, how we're bringing them to life. The first, of course, is New South Wales released its Smart Places strategy in 2020. So during the height of COVID in New South Wales, we were thinking about obviously increased use of data for all of the different activities that we used to deal with face-to-face. The use of data, the use of digital services was increasingly underpinning every aspect of our daily lives as we went through a lockdown period. New South Wales released its Smart Places strategy, which talks about some really important aspects about how we want to bring to life new developments and existing developments and different places within New South Wales. And there are some really important aspects to that. It's of course underpinned by data and digital. But importantly, the strategy talks about what we want to achieve in terms of outcomes. Outcomes described in principles-based language, outcomes which describe things like equity, skills and jobs development, health and well-being, but also bigger, higher-level outcomes, livability, sustainability, and resilience of communities. And against the backdrop of COVID and how we were seeking to continue to live and work and play and operate, it meant that data and digital was very, very strongly part of what we were thinking through with the release of that strategy. So the strategy also contains some very important references to digital twins, data sharing, security and privacy, and increased use everywhere of data to bring those smart places to life. Now, Transport for New South Wales also has their view of smart places, smart cities, and the role of smart infrastructure. On the left-hand side, there is this value pyramid that Transport for New South Wales sees their world. So as they're busily building out infrastructure, a smart train or a smart system, there's now the idea that they will build a digital twin alongside that piece of physical infrastructure. During the planning, the designing, the building, the operate and maintaining phases, Transport for New South Wales' view of the world is they should be constantly moving backwards and forwards between the real world, the physical world, and the digital world to better improve planning, to better ensure that as built matches as planned, so with fewer variations, but also to do things like, as the system is operating, to do things like preventative maintenance or predictive maintenance, and really to understand the implications of things like lockdowns on the infrastructure and the role then that smart infrastructure plays in smart cities. That's the left-hand side. The right-hand side are all the relevant standards that we need to think about when thinking about smart infrastructure and smart cities. And this is in fact far from all of them, but there are strategic standards, there are process standards, there are technical standards, which really get down to the nuts and bolts. And bringing these together, bringing the data and digital and technological components together along with the built infrastructure environment, what Transport is allowed then able to do much more readily is plan, construct, operate and maintain. But another way of seeing that is starting to understand the city, the place, the environment from the perspective of situational awareness, what's going on, root cause analysis, when something does happen, what is the basic cause of it, prediction or what if scenario planning, what if we did this, what if we did that. New South Wales has also been developing its digital twin from the perspective of spatial services. So just as Transport for New South Wales have a digital twin for their built infrastructure, and that rolls up into smart cities, the folks in spatial services have been bringing together foundational data sets to create a digital twin of the entire state of New South Wales. And for those of you who don't know New South Wales, it's the largest population state in Australia. Capital city is Sydney. And New South Wales has been building this digital twin by connecting fundamental spatial data sets together to build that model of the natural environment and also the built environment. And what that means is, of course, now we can start to work with that digital equivalent of the state of New South Wales for some pretty fundamental use cases, the situational awareness, the prediction, the what-if scenario planning. And this is publicly available information. You can go to the New South Wales Spatial Digital Twin website and see the sorts of things that they're doing. And as we move through our different layers of maturity, connecting in the spatial digital twin and the transport digital twin are areas that we're going to next. Now, in 2020, New South Wales also released its artificial intelligence strategy. And again, very much outcomes focused. We're talking about building public trust, building data capability, innovation and collaboration, digital uplift, and digital procurement, all wrapped around with the principles of trust. Now, as we constantly use more digital services, as we constantly use more data services, increasingly AI will be needed to make sense of those services, to be able to join them together for use in security, for use in personalization. And we know that the more digital services we use, the more we'll be reliant on artificial intelligence, which has the interesting implication or the interesting consequence that it actually enables us to make sense of that data and the sense of those digital services, which actually will allow us to make more use of data and more use of digital services. So artificial intelligence actually has the role of playing an accelerant in our use of data and our use of digital. And the expectation is, as we start to think through that world of 2030 and what it looks like and where people live and how people engage and how people go to work and how people get educated, increasingly artificial intelligence will play a more and more pervasive role in all of the digital services, as well as making sense of all the data that's created. So New South Wales released its artificial intelligence strategy last year, again, very much thinking about our sudden increased reliance on data and digital, but also acknowledging that these are trends that have decades of underpinning as we start to move towards an increasingly digital society. And of course, the artificial intelligence work in New South Wales, the strategy is underpinned by more of those standards. In this case, the most relevant one is from the world of ISO IEC JC1, it's Subcommittee 42. And Subcommittee 42 has been doing some great work around foundational use of AI, implications of governance, the data aspect itself, trustworthiness, use cases, and a whole lot of things which allow us to think more around safe application, appropriate application of AI on data and AI in terms of driving insights and driving decision making. That work, of course, is supported by a range of other standards areas, just like the Smart Cities, Smart Places work is supported by a range of other standards. But ultimately, it all depends on data sharing and data usage. Now, I mentioned during the worst in New South Wales, the worst of the COVID pandemic, we released our Smart Places strategy, acknowledging increasing fine-grained use of data. We also released our artificial intelligence strategy, increasingly sophisticated use of that same data. It wasn't until 2021, earlier this year, that New South Wales released its data strategy. Now, it may seem a little bit of we have an expression of putting the cart before the horse, doing things the wrong way around, to release the AI strategy and the Smart City strategy, both of which are uses of data, and then release the data strategy. But the practical reality, of course, is that data is the big game. Data is the really important aspect of what we're trying to do. We don't get to do the smart places, the smart cities, or even the use of AI if we don't know how to handle the data appropriately, if we don't know how to consider the uses, the concerns and sensitivities, the context of data sharing and use. So what we've done is to try and look at some fundamental aspects of data. And the first is to consider that data has a life cycle. And from the point of creation, transmission, storage, to analysis and then reuse, the use of AI is just one step in that data lifecycle. It's the analysis use case. Smart cities and smart places is also just a use of data in that data lifecycle. And this is quite a simplistic data lifecycle diagram: create, transmit, store, analyze, use, archive, then potentially delete. But it's a helpful way of thinking a way into what are, in practice, very, very rich, very cyclical data life cycles, which can have many, many, many loops. And the data can be transformed in many ways during that life cycle. But this was a really useful way for us to start to think our way into the problem and to think about not only all the issues leading up to the use of data, so the chain of custody, the chain of provenance, the chain of authorizing frameworks, data quality, all the things that we need to know to determine whether we had the appropriate authorizing framework to use the data, whether the data was fit for purpose, whether the data quality was fit for the use we were going to put it to, but also what we can do with that data once we've used it. If we use it for analysis, what can we do with the insights? If we put it through some AI, what can we do with the decisions? So we also focus very much on the metadata of the data as it travels through its data lifecycle. And of course, once again, we have spent quite a lot of time working with the standards community, again, ISO, IEC, JTC1, working with the folks who do cybersecurity, data management interchange, cloud computing, IT service management, artificial intelligence, and of course, digital twin. Another really important aspect when thinking about data sharing and use is to try and speak to the concerns that people have, the concerns that data custodians have at different points in that data lifecycle. Now, if you've ever had to ask the question of a data custodian, can I have your data? Even if it's de-identified, people-centric data, even de-identified, the answer very often is no. And the reason often given is because of privacy legislation. In Australia, we say because of the Privacy Act, the BOTPA reason. And the reason is justified if there is data about people, because we know even if de-identified, the potential exists to relink data sets and over time to move from data about a person, eye color, hair color, shoe size, to the reasonable likelihood of being able to re-identify an individual. That combination of features looks very much like John Smith. So the arguments given really relate to the level of personal information in a linked de-identified data set and concerns about re-identifiability. But in practice, if we think of the analogy of an iceberg, that's the part above the waterline. All the other reasons below relate to the governance, the sensitivity of the data subject. What are you going to do with the data? Do you have sufficient data quality for the use you're going to use it for? Do you have the right data for your use case? What is the consequence of the use of that data? What are the unintended consequences? Would I be embarrassed by the findings when you use that data? Are there potentially harms that are created by the use of that data? And what happens if the data gets into the wrong hands? So one of the things we've tried to do is identify all those sensitivities, including personal information, including privacy, and map them to a set of sensitivities. Currently, we're looking at 16. There are 16 because before that there were 15, before that there were 14. And we tried to map that to different phases of the data lifecycle, different stages of the data lifecycle, and then think about where we need to put the mitigating controls in place in order to best make sure that at every point in that data lifecycle, the person or the entity receiving the data ensures they have the authorizing framework, they understand the appropriateness of the data, and they understand what they can do with it, including the use case of analysis. We've also acknowledged that data is not all the same. And broadly speaking, we've talked about data which is both very sensitive and very personal. And it could be, for example, data sets we've created to address challenges of domestic and family violence, children at risk of significant harm. Very sensitive data subjects, very big, very substantial concerns about the use of data, very significant concerns about whether or not you have expert knowledge to use the data. But also, if we link fine-grained, very sensitive spatially fine-grained data, very temporally fine-grained data, we are going to create data sets which start to move us along that line of reasonable re-identification. So top right-hand corner, the governance has to be focused on both the sensitivity of the data subject and use, as well as privacy. But we know not all data sets are the same. Bottom right-hand corner, we build data sets based on the level of personal information, but also not necessarily, so focused on sensitivity. So our governance is really focused on the privacy component and less about sensitivity. And this is the sort of data we have when, for the transport system in New South Wales, we have a system called Opal. You tap on, tap off for a bus, a train, or a ferry. That's much less sensitive than data about children at risk of harm, but it also contains personal information that you could re-identify an individual if you could link those data sets together. So the governance framework is skewed towards privacy and less about sensitivity. Top left-hand corner, We're talking about governance frameworks which are based around sensitivity, but less around privacy. And that's sort of data that underpins a new infrastructure planning. So it's sensitive as to where you put it. It has a whole range of sensitivities for the community, but it's less about personal information because typically it's aggregate personal information which is used for infrastructure planning. And then we have data in the bottom left-hand corner which should be neither personal nor sensitive, which is data that we would release as open data. And what we want to do, of course, is develop data sharing frameworks that allow us to understand where we sit, governance which is appropriate for sensitive and personal, sensitive and not personal, not sensitive and personal, or neither sensitive nor personal. And in the cases that we need to use this data in a more broad environment, be able to not only understand where we are, but be able to push it into a different quadrant by increasing the level of protections by understanding the level of inherent sensitivity and the level of inherent personal information. And of course, what we want to do is do those smart city use cases, situation awareness, prioritization, prediction, root cause analysis, what if scenario planning, in order to bring it all to life, but understand the appropriate use of data at a temporal, spatial, personal, and relationship level. Now, one of the things we tried to tackle first in New South Wales was trying to come to grips with this issue of just how much personal information is in a linked, de-identified, people-centric data set. And as mentioned, if you have information, data captured about eye color, hair color, shoe size, for a whole lot of people, every person is a row, every column is a feature, there is a widely held view that if you keep linking data sets together, keep linking features together, at some point that level of personal information, that personal information factor, will cross over from having a level of personal information to being reasonably personally identifiable. So you could reasonably likely say that's John Smith. And this very simple figure just says that linking data sets together, personal information crosses over a personally identifiable threshold, and that reasonable threshold is represented by the epsilon. Just a very simple idea. So we've tried to actually quantify it. And I'm not sure how many of you feel comfortable with equations in presentations. If you don't feel comfortable, just look away from the screen for a moment. If you do feel comfortable, let me dive in and say, what we've tried to do is take an entropy-based approach to the information gain associated with rows and columns in a data set, which is based on the changing probability. And it works like this. If you know that row 2 is John Smith, and you know everything about John Smith except what's in column 2, and let's say that's day of year of birth, before seeing that column value, you might think it's any one of 365 days in the year, equally likely to be any day of the year that John Smith was born. After you see it, you know the value. And the change in probability from 1 in 365 to 100% is measurable. And that's something that we can then convert using logarithms to base 2 to say this is the number of bits of information that you gain. And then we say, if that was the worst case scenario for John Smith, then the most information you gain would be the sum of all of those different cell information gains, and we call that the row information gain. And what we've said is that the measure of personal information for a data set of linked, de-identified, people-centric data is the highest row information gain for the most unique individual in the data set. So those of you who are averting your eyes, come back again, the equations are over. Now that is a pretty clunky way to think about information gain, but it allows us to now think about how we would build the different governance frameworks depending on whether we're dealing with data which was of a high, moderate or low level of personal information, and of course the inherent sensitivity. And the flip side to that, this is possibly the busiest slide you've ever seen, the flip side to that is out of all the different possible governance structures, if we know how sensitive the data is and the use of data, and if we know how personal is the content of the data, we can start to build frameworks of control which we can put in place, which then say at this stage in the data lifecycle, the collect, the store, the analyze, or the use phase, these are all the things we need to think about in terms of our authorizing framework, our understanding of the data fitness for purpose, issues around the data quality, and then how far we can use that data in terms of how much we can rely on an insight, whether we can use it as a decision, and what we can then do with either the data itself or the data products, the insights, or the subsets of data that we've created as we leave that analyze or use phase and go on to the next phase of the data lifecycle. So we've described things in these controlled environments from very high control to high control, moderate control, low control, and then no control, where we release data to the outside world. And control, in this case, means we've got proven capability of the people or the entities that are using the data. We've got accessible governance, so our governance is appropriate for that stage in the data lifecycle for that level of control. And we've got a clear and verifiable purpose, which actually speaks also to the authorizing framework. Do you have the right to do it? Do you have the right to release it? Do you have the right to analyze it or store it, depending on where we are? And do you have the skills and capability to do it? And can we trust your governance framework? So what we've tried to do is map the nearly infinite number of possible ways of considering context for data use into 5. Very high control, moderate control, low control, or no control. Now I'm going to give you an example. I hope you're still with me. I hope you're still listening. I'm going to give you an example of how we really have done this with that smart cities example for COVID data. Now, when COVID hit in New South Wales, it was March 2020, there was a very strong push to release data as open data about what was happening. That situational awareness, tell me what's going on in New South Wales at, we call it postcode level. So in my suburb, tell me what's going on. And I want that information frequently, so daily, and I want it at fine-grained spatial level, hence the postcode. And I want to know really important things about the number of cases, likely sources of infection, the age group of those people getting infected, and anything else that we can know. So Australia, New South Wales, we looked around at what was happening in some other countries. We looked at New Zealand, Singapore, South Korea as examples. And from that, we built what we called our maximal data set. This is the most information we're prepared to release every day about what's happening in New South Wales across the entire state. And what we do is every single day, including today, we look at the entire set of data we've ever released right back to the beginning of 2020, and we calculate how much personal information is in that maximal data set. And we produce 4 data products from that maximal data set, all of which are intended to reduce the level of personal information so we can change the governance quadrant we're looking at in terms of release of data. So our maximal data set we call table 0. We measure the personal information factor for the data set. So that's the highest information gain row for the most unique individual. We've looked at our 4 data products we create, which are each subsets in some way of that maximal data set. And we measure the personal information of those data sets as well. And what we try to do is ensure the red curve is the cumulative distribution function for the data set, and that red circle around the red curve is the personal information factor. So that's the limit. That's the most unique individual, the highest row information gain for the most unique individual in the joined up data set. And for our data products, where we've broken the table apart or we've applied extra protections, we try to reduce every day the personal information factor for those 4 tables, table 1, 2, 3, 4, to a certain ratio below that maximal data set. And if we hit that threshold, if we drop personal information factor by the appropriate ratio, we release the data. If not, we take extra protections, we apply extra protections for the data, which means we may hold back, we may omit, we may aggregate further, we may obfuscate in some other way. And what it means is effectively what we're doing from those governance frameworks is we collect, store, analyze that data in very high control environments. It comes from the Ministry of Health, it's passed through a secure environment. That maximal data set is analyzed in a secure environment. Those data products are analyzed in a secure environment. And if we meet the requirements, we then move the data products, not the original raw data, but the products we've created from that data set, out into a no control environment. We release it as open data, where there are no restrictions on the use of the data, no restrictions to the other things you can do with the data set. So we've tried really to think through the data collection, storage, analysis, and use, and also to ensure that we are operating at one level in a very high control environment with the intention of releasing data products into the next stage of the data lifecycle where there is no control over the use of that data. And this, of course, is what we release every single day. As mentioned at the very beginning, it's our situational awareness map. It gets updated every single day with confirmed cases and a whole lot of information, which ultimately is that maximal data set. But the raw data gets released in such a way as to not allow that re-identification, not allow that re-linkage, and reduce the level of personal information. So in effect, what we've tried to do is take sensitive and highly personal data, top right-hand corner governance, and push it to the right-hand side by reducing the level of personal information, and also by taking steps to protect the linkage of data sets to reduce by some factor the level of sensitive information. And again, getting back to our smart cities analogy, what allows us to do is situational awareness, which is the most fundamental use case of the smart city, which then means we can start to think about linking data sets together with digital twins, with other aspects about smart infrastructure to start to look at prioritization, prediction, or what-if scenario planning. So a bit of a whirlwind, but thank you very much for listening. Really, the point of all of this is that New South Wales has been going on a data journey. It's been a long process, and we know that we are deliberately but cautiously moving forward in our thinking about appropriate use of data, whether it's for smart cities, whether it's for AI. We are building a whole series of additional assurance frameworks and governance frameworks around our use of data for the many, many different uses of data, and trying to understand the data itself and what the appropriate level of control is to ensure that people have sufficient comfort so that when the next stage of the data lifecycle, they hand over either data or data products, they do so with confidence that the controls are in place, the necessary controls which are appropriate for that next stage of use. And of course, we're constantly relying on the world of standards. Thank you very much.